So we just got past radiation. In specific to that is thermal radiation. We are looking into thermal radiation. So under thermal radiation, you or us and we, so we happen to come across a statement that we have two laws that will help us talk about any body absorbing and emitting heat, right? Radiation basically. So with radiation it absorbs, with radiation it emits. So to govern that, to help us understand that, we have the first law, Stefan's Boltzmann law. Stefan. Basic idea about this law is that this law quantifies the power radiated. So it's able to quantify matlab, it's able to give a numerical value to the power radiated. So total power radiated per unit area of a body is proportional to the fourth power of absolute temperature. Fourth power is pretty, that power is pretty good. I mean, fourth power is exponential growth, right? So the formula is, all these are constant, and t to the power of 4. So the constant involves Stefan Boltzmann constant. A, your surface area of the radiating body. E is emissivity of the surface. We'll understand this. T is your absolute temperature. See, this rho thingy, this constant thingy, it's a constant that I can't do much. A is your surface area. Easy to understand. This is emission. I'll call it as emission. I'm pronouncing it all wrong, I guess. So this emission thingy is, it has a value between 0 and 1. So whenever you get values between 0 and 1, it's always related to something. So let's look at it. So this emission thingy, so basic idea of this emission is that how good a surface is at emitting radiation. So it talks about, is it good or bad? So obviously 1 is good, 0 is not so good. Okay. So I told you, and whenever you get any value between 0 and 1 and stuff, it's to do with ratios. It's like a thumb rule. It's common sense actually. So refractive index, you get this integer decimal number confined between two numbers. So it's in relation to something, right? Refractive index is one of them. So the ratio of radiation emitted by a surface that we are dealing with to the emitted by a perfect black body. Again, you have ideal gas, ideal that, ideal this. So we are talking about perfect black body. This too, we are going to define full-fledged, but now we are just using the phrase. You can imagine what is a perfect black body. So we have this statement over here. A perfect black body at the same temperature. So if you have a perfect black body in front of you and the object that you are considering, if you want to get the E value, throw the same temperature at them. Have them at the same temperature. Look at how much radiation is happening because of them. Right? You have them at the same temperature. You observe how much energy they are radiating. And take the ratio, and that will give you the E value. So E being 1 is a perfect emitter and perfect observer, and 0 being perfect reflector. They emit nothing. But of course, real object lies between 0 and 1. So 0 being obviously not so good emitter, 1 being almost good emitter. So I think I have that also. Surface behavior, a black, rough, dull surface have larger emission. Let me tell that. A shiny, polished, metallic surface has low emissivity, close to 0. Okay. I think I have a flow chart. Okay, guys. So yeah, if you guys want to write this off. So we started with radiation. This particular video is linked to radiation. So radiation in specific, we are talking about thermal radiation. Under thermal radiation, there are two laws that governs or helps us understand quite a few phenomena. And of course, the main phenomena with radiation is absorption and emission. So when we talk about radiating, the power of radiation, at what pace the energy is, the body is emitting a radiation. If you want to figure out that, we can use this formula. And this formula is related to temperature, absolute temperature, right? That is, you are measuring in Kelvin. So the constant, two things are simple and straightforward. We have a value called as E, emissivity or emission. I mean, don't read it as emission. That's me just telling. So this is to do with comparison with black body, a perfect black body. So it's as soon as you throw something at a perfect black body, it absorbs, not leaving out anything. And it is also a good emitter as well, right? So that ratio and all of this definitions has to be very precise. We can't mess it up. And so we get a range of 0 to 1. Okay. So that's your E value, the emissivity. Okay, guys, so you can have a look, write it down.